Problem number 813, largest sum of averages. You are given an integer array nums and an integer k. You can partition the array into at most k num-empty adjacent subarrays, and the score of a partition is the sum of the average of each subarray. Okay, note that the partition must use every integer in nums and that the score is not necessarily an integer. Okay, so return the maximum score you can achieve of all the possible partitions. Okay, so yeah, it looks like we just have written a problem that to find the to partition the array into at most k element in a group, but the previous problem is to calculate the maximum sum multiplied by the length of the group. And for this, it wants to calculate the sum, to calculate the average of each group and sum it up for every group. So yeah, I will check if the score of a partition is the sum of the averages. Okay, yeah, so like calculate the average of each partition and then sum up every partition. Okay, and we want to find the maximum score. Okay, so we cannot have like empty partition. And the length will be at least 1, and k will be smaller or equal to the length of the nums. Okay, so we will have if we look at the last element, we can say that is, if we pick the last element like nums I, is selected into a group, then the problem shrinks to nums. The problem shrinks to finding the max score in the rest of the array, and that is nums 0 to nums I minus 1. And we can have another option or if nums I minus 1 to nums I is selected, then the problem will become finding the maximum score in the rest of the array that is 0 to I minus 2. Okay, so and okay, we also need to, and for the score calculation, we also have to, like, if nouns is selected, then how can we calculate the average? It will be like the previous average, multiplied by group length, you can have like this, the current group length you should minus 1, and plus the current plus nums I, and multiplied by group length. Like, this is the average, and yeah, you should, like, for every yeah, we should add up the average. And oh, because there is a limitation of k, so like here we can only have like till like the last k elements is selected, so it will be n minus k. Yeah, like for this. Till okay, not, but I minus k plus 1. Yeah, like for this. Yeah. Okay, I is selected. The problem will become 0 to let's say I minus k. Okay, then yeah, and we will have boundaries like like I minus k yeah, I'm thinking of if I minus k should be if it is 0, then we can still select non-zero. So I think if I minus k is smaller than 0, then it will be an empty array, and the maximum score, like its score will be 0. So Okay, and let's start it with defining n as the tens of nums, and we will have for loop. We'll have it. We can. Sorry, I forgot. As for each like for each selection ending with I, like for the subarray ending with I, there is like n-1 selection to try, like this 2, 3, 4, and 5. No, sorry. If you have selected this, then you can have, if this is the FSI, then you can have like the selection will be, you can have K, like K, the count of K selection, so it is like a tree. So I would like to use that for search, and it will be so the FSI will be defined as the maximum score with the partition with the maximum score of the array as of the array nums 0 to nums I, that each partition then is not larger than K. Okay, so then we will start from the implementation of the FS, and the boundaries will be, let's say, we will do it later on. We will first to do boundaries, and we will move on to the stuff outside the boundaries. So then we will have max score with 0 first. Then for J in range, we will have we will start from I minus we will loop through this, so we will start from I minus K plus 1 and end it at I plus 1. Then we will have J till I and start it from I minus K plus 1. Okay, so for this, like, so we are trying to calculate the maximum score of each selection, and the max score will be the max. Okay, how can we calculate the max score? Oh, sorry, it will become df as j minus 1 plus the max score. So it will be, yeah, like it will be the previous average group length okay, so I'll have group length. The current group length will be it's I minus j. Oh, but j will be I, so it will be I plus 1 minus, yeah, I minus j plus 1. And okay, so it will be, and the previous average, like I will have average here, and it will be yeah, like the smallest value is 1, so I will have average to 1, and the current average will be previous average multiplied by the group length and plus the current value. Okay. Yeah, since we are enumerating this, I minus 1, I minus k plus 1. Oh, but for like, we should do it in a reverse way. So we will start from I and end it at I minus k. Yeah, and the steps has to be -1. Okay, then this will be the average. Yeah, for the first one, this will be 0. This group length is 1, and we should divide it by group length. Yeah. Okay. Then return the max score, and let's go back to the boundaries. So like, okay, if k is 3 and if I think this will have like j will be, for this j should be 0 or j should be -1 if okay, if the selected one is I, then if we cannot select, then it like the first will be I, and then the last one will be 0 to I, and the length should be k. Yeah, so this is correct, but yeah, the boundaries are okay, so if j is, let's see, if j is 1, like if this is so only if I minus k is -1, then we have nothing, like the problem shrinks to, yeah, there's no, like we have met the boundaries, because if I minus k is 0, then we still have one element to select. So so if I minus k is, if like I think if I is 0, I will say if I minus k is -1, if this is -1, then this will be 0 with I I will say if k is 3, then I minus k is -1, then I is 2. So if I is 2, and 0 till 2 is selected, so it will be like this. This is selected, then like j will be 0. Yeah, j is 0, then DFS negative will be will be 0. Or maybe let's just try if I minus k is smaller than 0, then return 0. But I minus k is j. Like, I don't know, like, okay, we will start from return dfs and minus 1, and okay, let's see this. Let's try run. So n is 5, so it will have dfs 4, k is 3, so I minus k is 1, so this will be for j in range I is 4 now till 1 with the negative sets. So you will have group length. We'll have length. Let's say g length equals okay, so 4 and a3, we will have, okay, first of all, j is 4 now, so we will have the length I is 4, G is 4, 1. So it is like stacking line. And yeah, stacking 9. So J is 4. Average will be, the previous average is 1 multiplied by the previous length, it will be 0 plus 9 and divided by 1. And we will check the next the rest of the array, which is DFS 4 minus 1, 3. So we will check 3. With DFS 3, we will have for loop J in range 3 till 0 with the negative steps, and J will now be 3, which is this. So yeah, like by selecting 9 we to a group, we will now see this, and we will select 3 as a group, and for 3 as a group, we will calculate everything and then we get down to DFS 2. So this one, and we will have J is 2, J minus 1 will have DFS 1. oh sorry, for 2 we will have for j in range 2 till -1 negative steps, and then for 1 we will have DFS 1 we will have for loop j in range 1 till -2 and -1. Okay, I think like for here we should do a maximum, like the last like if I is if I is 2, then you can like you can have 0 to 2. Is it 0? So yeah, j is this thing. Yeah, like, and this is okay, but for 1, like you cannot select if like I is 1 and j if I is 1. Like this one is selected, and yeah, like if I is 1, then I minus k plus 1 should not be larger than, should be 0. Like the last thing should be 0, so it should be -1. And okay, so j will be 0, and for I is smaller than 0, so this is like I is 2, I is 1. Yeah, for I is 1 it is still working, like this will be -1, and you will have 0 to like this 0 to 1 selected, and you can have 0 to 0 selected, and DFS is 0. So I is 0 is accepted, but you cannot accept I is smaller than 0. So if I is smaller than 0, we have nothing to select, it's an empty array, so we'll return 0. I think that's fair enough. Let's see. Not sure if it's the average is wrong. Like, okay, let's don't go down. we will have G length is 1, and the average is correct. So we will have 0, maximum score 0 compared with this thing plus the average. Like it's 9 divided by 1. Maximum score, yeah. And then if it's okay, so J will be one step lower. It will be, so if J is 3, group length will be I is 4, so 4 minus 3 plus 1 is 2, so J is 3. This was this. Okay, so 2 is correct, and we will have average will be, the previous average is 9, so it will be 9 multiplied by the previous length, so it's the length of now, V1 plus it's J is 3 now, so it will be, the value is 3 as well, and divided by 2. It's kind of correct. Yeah. Maybe let's see. Okay, so we will have DFS 3. So for DFS 3, it is for 3 in range. Okay, sorry, for J in range. For J in range, I3 till 0, like this, and if we have J, so J will be equal to 3. Let's say if we have J, if J is 3, then the length is 1. Is it correct? Yeah. And average will be, it will be 1. So it's 1 with the length 0 plus 3. And yeah, it will be 3 divided by 1. So it's 3, right? Average is 3. And yeah, we want to move on to the next iteration, so we can have this 1, 2, 3, and so we will add it. Like now J is 2, so we have I is 3, J is 2, so the group length is 2, and it will be 3 multiplied by 1, since 2 minus 1 is 1, so 3 plus current value is 2, is 5, and 5 divided by 2. So it will be 2.5. And then let's move on to the next. It will be j is 1, and so it will have 3 minus 1 is 2, 2 plus 1 is 3, and this is 2 multiplied by is 5. 5 plus 1 is 6, divided by 3 will be 2, so it is 2. And you will have DFS. J is 1, so you will have DFS 0. And for DFS 0, it will be range for J in range 0, 0 minus k is -2, so it will be -1, -1 steps. And so group length will be 1, average will be 9, and yeah, and you'll have DFS -1, so you'll have 0, 0 plus 9, 9 plus not sure why it is wrong. Check the solution. Gemini said, oh, I can only separate the k adjacent. Okay, the number of partition is k is not like it's not each partition can only have k elements. Okay, then I'll have to restart the thing. So I think we should add k into the parameter. So like the maximum score of the array that and it's at most k, so you don't that the number of partition is not larger than k. Okay, so if noms I is selected into a group, the problem will become finding the maximum score in the rest of the array, and will have this with there, like average thing, we will have this. But for array, I think I will add with k, with at most k minus 1 partition. Yeah. So I will have and k should not be smaller than 0. If then we will return 0 as well. So if I is smaller than 0 or k is smaller than 0, I with k, so yeah, there's no like yeah, like you can stack till 0. Like if the whole thing is selected, and the problem will become no, there is no problem. Like it will be till and this is empty. So it will be, yeah, it will be j, the minimum of j can be 0. So I will and you will have k minus 1. Yeah, since you selected 1. Okay. Oh, this should be k. Now, you will have k if k is 0, well, maybe if k is 0, then you cannot run. Like if this is 3, so you can do a partition, then it will be 2. You will have 2 partition. So if Yeah, like this is correct, but this is not correct. Oh, but if you select the whole thing, then you only have, yeah, like if you select you only have like K partition. Oh, so like you have 3 partition, like the limitation of partition is 3. So so like before this, you own, like when you select, then you will minus. I think you have to minus. I'll have K minus 1. And no, you cannot do that. Yeah, when it reached 0, you cannot do the partition. And if J is 0, K will not change. So I'm not sure, like if this is 0, still not helping anything. Not sure if like if k is 1, yeah, then you can only do. Now if k is 1, you cannot do any. So if k is if k is 1, you can only stack the whole thing, and I'm not sure, should I like separate like if I is smaller than 0, then return 0, and if k is 1, yeah, like you cannot do the partition at all. But if k is 2, you can do 1. So I will say it's like this. No, return if k is 1, then the length is also 1. So I'm not sure what I want for this. It's weird because I don't want okay, maybe it's weird since if the default value is 1, so I will have 0. But then I don't see I'll ask AI. stay with k equal to 1, and I have to make some, like, we can only select the whole thing. So if I is smaller than 0 or return 0, and if k is equal to 1, then you have to return the whole, like, sum of nums num 0 to I plus 1. I'm not sure why this is like this is wrong. Or maybe we will not use yeah, like if we use like a stupid approach, like a brute force, like we will calculate, but this is like we will have the sum. No, average will become sum of nums j till I plus 1 and divided by the group length. Okay, so after asking Gemini, I forgot to, this is the total sum of the array, but I did not average it. So yeah, this should be divided by I plus 1. And yes, that's good. Okay, let's see. Okay, yeah, like using the sum is really, like, it is, I think it is the bottleneck, and we keep slicing the array. So yeah, we should optimize here. So I would like to do so I keep track of the average. Here, so it will be the previous average, and for here it would be, since it is reversed, so j will start it from I, and so the average will be yeah, like the previous average multiplied by the group length before, or maybe previous group. Like I think group length -1 will be okay, and this will be the previous sum, then previous sum, and then add up, and then we will add nums j and then divided by group length, then it will be the average. Let's see if this works. Let's see if it's faster. Okay, faster. But also here, like yeah, I'm not sure if, or maybe we can do it like, I don't know if max score and average is here. No, only max score is only average is there. Then but this is the previous average. Yeah, I'm not sure if no, I don't think. Yeah, this you should add it yourself. I cannot optimize that much. Maybe let's change to for loops. So then we will have to create an array that keep tracks of the max score of each subarray ending at I, and the array will call it max score, and the dummy node, we will have a dummy node, since if I is smaller than 0, it should return 0. So for a dummy node, and other default value will be 0 as well, so that we will have the length n+1, and then we'll start our for loop. So it will be for I in range n, and if k is 1, then max score I+1 will be sum nums to I+1. And divided by I+1. Okay, and so we'll have average equals 0. So for j and range reversed, it will start it from I and end it at 0. So it will be -1, and the steps will be -1. Yeah, so I think we can copy here. Yeah, so group length will be I minus j plus 1. Average will be calculated like this. So max score I plus 1 will be max score I plus 1, and this will be max score as well. It will be we should create like since it is I and K, we should create a matrix. So let's say we'll have K columns, and for range in and plus 1. So for max score, it will be okay, we should for loop K as well. Yeah, for K in K, and the K, like K started from 3. If K is given as 3, K will start it from 3 and end it at it will, let's say it will end it at 1, and it will be reversed. So so for every K equals 1, it would be the sum of okay, and this will be inside the K loop, and the max score Ki plus 1 with K equals K will be J, and K minus 1 plus average. Then we will return max score and K. Okay, list out of range. J, the largest J is I. and the smallest j is 0. I think I found, like, it says index out of range, so I think it's here, like here. Yeah, since k started at 3, then for 3, but we only have 2, so remove this, then that's run. Okay, somewhere is okay, k started 3 and ends at 1. Yeah, 3. The contract with the solution. Okay. Not sure why it is plus 10 here. Oh, I'm thinking if does this need to add 1? Since like this will be 3, so you will be put it at 3. Okay, let's ask Gemini. Oh, it says that when finishing I should break. Yeah, because if I don't break, then it will run into this code. Oh, it's still slow. Like, okay, let's say time complexity. Time complexity will be n big O n multiplied by k multiplied by j. No, n. Yeah. Okay, I have seen the solution. Like, it use a prefix sum to make counting the sum or average easier, and like for this it won't cost big O(n) time. So okay, let's change it to prefix sum. So for prefix sum, we'll have prefix. We'll have an array called presum, and it will be equal to 0. We will have a dummy node for 0. Yeah, since there may be conditions that like when using prefix sum, it is like using it means like like when you are standing at the ith element, it will be the sum of all the elements before. So I will say presum I equal is like the I element I will say the sum of nums non-zero to I. Yep. So for for I in range n, presum will be presum I plus 1. Since we already have when I is 0, it is 0. It is yeah, it is an empty array, so it will be 0. And pre-sum I plus 1 is pre-sum I plus the previous sum plus current value, so nums I. Okay, then for this sum, we will have, this can be rewritten to, I'll write it here. Yeah, it will be pre-sum of I plus 1. And for the sum, the average here will be since yeah, this will be selecting nums, nums j to nums I, and it is, yeah, and it can be written to nums j till I plus 1. So the sum will be prefix I plus 1 minus prefix j. I'll say I think this should be, oh yeah, this is correct then. So this is the sum. We don't need the average before. Okay, then let's see. It's pre-sum.